Today's lesson is on writing and solving proportions. Let's start by defining what a proportion is. A proportion is an equation that states that two ratios are equivalent. So let's give a couple examples. First, a numerical example. 3:5 as 6:10. So this is an equation. I've got a ratio on either side, and the proportion here says that in this equation these two ratios are equal. The way we read this is we say 3:5. That is to say, we're saying the relationship between 3 and 5 is as 6:10. So again, 3:5 as 6:10. We might have an algebraic proportion. And this one will be read A is to B as C is to D. So these are two ratios, and the proportion states that they're equal. Basically, any proportional relationship is where the ratios are equivalent, like we've been using over the last few days. So that's how we write and say a proportion. We're going to look at three ways today to solve them. Okay, the first is using equivalent ratios. So equivalent ratios, it's nothing new. This is just like finding equivalent fractions and so forth. So problem A, we will use 1:5 as Z is to 20. All right, so I've got a fraction of 1:5, and I know it's the equivalent to Z over 20. So what I'm going to do is say, well, what is the denominator multiplied by? It's multiplied by 5, or by 4 rather. Excuse me. So it's multiplied by 4. So in order to be equivalent, the numerator needs to be multiplied by 4. So 5 times 4 is 20, and 1 times 4 is 4. Z must equal 4 for that to be a proportional relationship. Let's look at one more example. So that 27 is to C as 9 is to 12. Okay. Well, in this case, I see there's a relationship that 27 is 3 times 9. So I'm going to go in this direction and say 9 times 3 is 27. So 12 times 3 must be what C is, if they are proportional. So C must be equal to 36. And that's how we use equivalent ratios to solve for a proportion. We identify what happens to either the numerator or the denominator, and we multiply or divide the other by the same scale factor. So that really we're just multiplying by 1 in this case. So when we do 1/5 times 4 over 4, we're just multiplying by 1. You get 4/20. When you're over here, and if you're going this way, you're multiplying by 3 over 3, which is the same as multiplying by 1, and you get 27 over 36. If you were to look at this from left to right, it'd be dividing by 3. So it'd be dividing by 3 over 3, which is just dividing by 1, and you'd get the 9/12. So equivalent ratios is the first way that we can solve proportions. The second way is simply by using algebra and the inverse operations that we've learned to apply in our last unit. So in example C, we'll use the proportion 25 is to 30 as x is to 12. Now looking at this, there's no really obvious equivalent ratio. 12 doesn't fit evenly into 30. So equivalent ratios isn't probably going to be our first pick. So let's just use algebra. I'm going to draw a line under the equal sign and say, well, what's happening to the x? It's being divided by 12. So how do I undo that operation? I'm going to multiply both sides by 12. Those cancel out. This is just the way we did it on our equations unit before. Now I've got x by itself, and over here I have 12 times 25 over 30. I'm going to cancel out some common factors before I do any multiplication. I see that I can pull out a 6. This becomes a 2 and a 5. 25 becomes a 5, and this is a 1. So I really just get 2 times 5 is 10. I'm going to check that first to make sure it makes sense. 10 is to 12, so 10 is most of 12. Just like 25 is most of 30, the answer seems reasonable, so I'll go ahead and box it. In example D, I'm going to say that 14 is to 4 as 49 is to M. Now again, if I was to use equivalent ratios right off the bat, there's no obvious scale factor. 14 doesn't go evenly into 49, so we're going to use a simple algebraic method. There's a problem here though, and the problem is that the variable's in the denominator. So you can't really answer the question, what's happening to the M? It's 49 is being divided by M. That's what's happening to the 49. And so we have two options. Let me show you the first option. The first is that I can simply just flip both sides and rewrite the proportion. Now it's 4 is to 14 as M is to 49. Now why can I do that? Well, for the same reason when we made our ratio tables, it didn't matter which one you put in the numerator and in the denominator as long as you kept them the same. Right? 14 divided by 4 is going to give you that relationship, that unit rate, just like 49 divided by M will. But if you flip it around, remember when we were comparison shopping, you could compare dollars per pound or pounds per dollar. As long as you keep it straight, it doesn't matter. So in this case, we're just flipping it around so that it's a little easier to work with algebraically. And now I can see that what's happening to the M is it's being divided by 49. So the inverse operation is going to be to multiply both sides by 49. Those cancel. The M is now by itself. And I'm going to look for any common factors here. I know 7 fits into 49 7 times and into 14 twice. 2 fits into 4 twice and into itself once. So my denominators have all canceled. I get 7 times 2 is 14. Let's check to see that it's reasonable. 14 is, well, it's 2/7 of 49, right? And 4 is 2/7 of 14. So that works out. So that's option A in terms of solving algebraically when the variable is in the denominator. Let's look at the same problem, but we're going to look at a separate way to solve it. Okay, in this case, I'll go ahead and draw my line directly. I just want to get rid of this denominator, and I want to move the variable into the numerator. So all I'm going to do is multiply both sides by the denominator. And see what happens when you multiply the right side by M, they disappear off the right side. And now it's just on the left side, but it's in the numerator. It's up top now. So now I have M times 14 is equal to 49. This all over 4. Well, it's still, now I have what's happening to the M, and I want to get rid of this denominator. So if I multiply both sides by 4, those cancel. Now I've got M times 14, or 14M, is equal to 49 times 4, which is going to be 196. Okay. Now using inverse operations, I can divide by 14. And M is going to be equal to whatever 196 over 14 is. It looks like 1 and then 4. So M is equal to 14. And then we'll just check. So 4 is a little less than a third of 14. 14 is a little less than a third of 49. So it seems reasonable. I can go ahead and box it. I just want you to see what the two steps were. It's going to help us with our next way to solve proportions. We multiplied both sides by this denominator, and then we multiplied both sides by this denominator, and we ended up with no fractions remaining. There was no ratio anymore. So that's going to lead us to the third way to solve this problem. I'm still going to do a third way of the same problem. 14 over 4 is equal to 49 over M. This way is called the cross product. basically, I'm going to take this denominator and multiply it by that numerator. I'm going to do these steps all in one. So this just becomes 14m. And on the other side, we're going to multiply it by this denominator. So this becomes 49 times 4. And then I can solve the problem just like I did starting at this point. Okay, this is called the cross product. And all it is taking the algebra, the algebraic method of solving this proportion, which took 2 steps to get to an equation without any ratios. And we're just going to do it all in one step, because we recognize that if you multiply both sides by the denominators disappear and they come to be the numerator on the other side. So let's look at two problems using the cross product directly. This is the cross product. Example E, 8 is to 6 as 12 is to x. Alright, so I'm just going to go directly to cross product and say that means that 6 times 12 must be equal to 8 times x. All right. Again, all I'm doing is I'm just assuming that I'm going to multiply both sides by x first. It cancels out on there on the right. And then I'm going to multiply both sides by 6. And that will cancel out on the left. So then I can just simply draw my line here. 6 times 12 is 72. So 72 equals 8x. Divide both sides by 8. And x is equal to 9. Check to see if it's reasonable. 6 is 3/4 of 8. 9 is 3/4 of 12. So that worked out just fine. And our last example, a is to 4 as 28 is to 14. Okay, again, go straight into the cross product. So this is 14a is equal to 4 times 28. So 14a is equal to, let's see, what is that? 4 times 20 is 80. 4 times 8 is 32, so that's 112. Divide both sides by 14. You get a is equal to 112 divided by 14. Let's see. I'm going to guess 8. Three, 12. And that goes in there evenly. So a is equal to 8. We check to make sure that it makes sense. 8 is twice 4, and 28 is twice 14. So the cross product worked out there. So your homework tonight is to solve these 6 problems. They are scanned on our web page using the 3 different methods. So that A and B, you'll use equivalent ratios. C and D, you'll use inverse operations to solve algebraically. And then E and F, you'll use the shortcut, the squished butterfly cross product. There's a challenge question there for those of you that choose to do it. And we will review your homework in the morning. As always, please do this on your own to the best of your ability. And we will go over it when we get back into class in the morning. Use it as a self-diagnostics tool.